Today we're going to talk about combining functions. And we are going to focus on addition, subtraction, and multiplication today. We'll do a couple of different combining function operations in the future, but these are the ones we're going to look at today. Definition. Suppose we have two functions f and g. The sum function f plus g is defined by f plus g of x equals f of x plus g of x. The difference function f minus g is defined by f minus g of x equals f of x, you guessed it, minus g of x. And the product function f times g is defined by f times g of x equals f of x times g of x. So what does this mean exactly? It kind of looks like we just jumbled around some symbols here. What I want to sort of make sure we're aware of is that really what we're doing here is we're not just shifting around where the plus sign is or where the minus sign is, we're actually creating a new function. So let's look at f plus g for a second. We're creating a new function where if I plug in x, what I have to do to get f plus g of x is add f of x plus g of x. So I'm creating a new function out of f and g. If you'll recall this sort of notation from before. So we're creating a new function with the name, we're calling it f plus g. Right? Again, f and g are just names of functions. F plus g is the name of a function where the function just means that we add the output from f at x and the output of g at x. So let's look at an example of this. So let's let f of x be 2x plus 3 and g of x be negative x plus 2. First of all, before we look at f plus g of x, let's look at f plus g of 1. We're looking at f plus g evaluated at 1. That's what this means. So we're plugging in 1 into that kind of function machine named f plus g. That function machine tells us that we need to add together f of 1 plus g of 1. What are these? How do we find them? Well, pretty simple. We just plug 1 into f and 1 into g, just like we normally would, right? So f of 1 is 2 times 1 plus 3, which is 2 plus 3, which is 5. G of 1 is We replaced x with 1 here, so we need to replace x with 1 here. So we have negative 1 plus 2, which is 1. So f of 1 is 5. Let's replace f of 1 with 5. And g of 1 is 1. Right, so we have f and g. And then we add them together and we get 6. All we're doing here is replacing things with more useful things. One thing I like to tell my classes is that in math, once you get to kind of this point and beyond, really all we're doing is replacing things with more useful things, right? So here we had this function called f plus g of 1. We're replacing that with the more useful f of 1 plus g of 1. Then we can figure out what f of 1 is. Right, we replace x here with 1 because that's useful for what we're doing. We end up with 5. We replace f of 1 with 5. We do the same thing with g, and then we add them together to get 6. That's the answer. Let's look at f minus g. And this time, let's look at it with x. So now we're looking for a more general form with x. Not so bad. Again, our formula, right, tells us that this function is just f of x minus g of x. We want to replace things with more useful things, right? F of x is equal to what? 2x plus 3, right? And g of x is equal to what? We're subtracting, so we want to have that negative. G of x is equal to negative x plus 2. Is it important that I have these parentheses? Totally, especially in this case, right? When we're subtracting, we want to make sure we're subtracting this whole thing, right? So if I didn't have these parentheses here, yeah, I would subtract this minus x, but I wouldn't know to subtract this plus 2 as well. But since we have the parentheses, we know we need to distribute in order to simplify, if we need to simplify. First of all, I want to make the note that if the question doesn't ask you to simplify, don't simplify, right? Waste of time. And it's you run the risk of making a mistake while you're simplifying. So just don't simplify. If it doesn't ask you to simplify, don't simplify, right? So if this didn't ask us to simplify, this would be a perfectly acceptable answer. However, if it did ask us to simplify, what would we need to do? Well, just like we were talking about, we would need to distribute this negative, right? So we end up with 2x plus 3 minus negative x, which is plus x, minus 2. We can combine like terms here. We've got these two x terms. We add them together, we get 3x. We've got these two constants. We add them together, we get plus 1. This is all f minus g of x's. Simple as that. If I had been looking for f plus g of x, I would simply replace this with a positive, right, and add them together. That's all. Let's look at f times g of x. So what is f times g of x? What does our formula tell us this is equal to? Well, f of x times g of x, right? So what do? I just replace f of x and g of x with what they're equal to. F of x is equal to 2x plus 3. Again, I need to keep these parentheses, right? very important here as well. G of x is negative x plus 2. I need to keep these parentheses. If I didn't have these parentheses here, it would look like I just need to multiply 3 times negative x, right? Is that what we're doing here? No, we're multiplying two binomials, right? In order to multiply this by this, I need to FOIL, right? I need to multiply these terms, and these terms, and these terms, and these terms, right? So we definitely want to make sure that we keep these parentheses around when we're doing this. It's very helpful. Again, if it didn't ask us to simplify, we wouldn't have to do anything, but let's go ahead and simplify for the practice. Again, like I just said, we need to multiply all of these terms together, so we need to FOIL. FOIL stands for first, outside, inside, last. First terms, what that means is we multiply the first terms in these two binomials. We've got 2x times negative x, which gives me negative 2x squared. The O in FOIL stands for outside, so we multiply the outside terms. We have 2x times positive 2, also known as 4x. The I in FOIL is inside, so we multiply 3 times negative x, we get minus 3x. And then last terms, L in FOIL is for last. We multiply 3 by 2, we get 6. We can simplify this by combining these guys. So we end up with negative 2x squared plus x plus 6. This is the answer. Okay, now just to kind of tie it back and see how this can be used, let's say I had asked for f times g of 1. Well, our formula says that this is just equal to f of 1 times g of 1, right? How can we solve this? How can we figure out what this is equal to? Well, again, we just replace things with more useful things. We already know what f of 1 is and what g of 1 is, right? We found it out earlier. It's 5 and 1. Except instead of adding them together this time, we're multiplying. So we have 5 times 1, which is just 5. So how does this tie in with what we just found, f times g of x? Well, f times g of x, if I know that it's equal to this, then shouldn't f times g of 1 be equal to this with the x's replaced with 1? Let's check it out. So we can either solve it this way, or let's see what happens if we replace the x's here with 1's. So we have negative 2 times 1 squared plus 1 plus 6. 1 squared is 1, times negative 2 is just negative 2. Negative 2 plus 1 plus 6 is 5. Right? So this gave us the same answer. Great. Okay, now that we've looked at it kind of symbolically, let's look at this graphically. So let's turn to the combining functions by addition, subtraction, and multiplication section of the lab manual. So here, this first question is asking us to graph the function f of x plus g of x. We know that this is just the function f plus g of x, right? We have a name for it. So how are we going to do this, right? We don't know what f of x is and we don't know what g of x is. Let's just take a quick look at a single point and see what's going on. Let's say we're looking at f plus g of, I don't know, negative 2 looks like we have some pretty solid points that fall right on grid lines. So let's look at that one first. So f plus g of negative 2. Our definition tells us that this is f of negative 2 plus g of negative 2. Well, what is f of negative 2? We don't have an equation, but we do have the graph, right? F of negative 2 is the y value of f at negative 2. Let's really quick mark these so we know which one's which. Directions say f is the solid line and g is the dotted line. Same thing down here. F of negative 2 is the y value of the function at x equals negative 2. Y value here looks like 6. G of negative 2 is the y value of the dotted function at x equals negative 2. Y value here looks like 0. So, f of negative 2 plus g of negative 2, we can add them together. We end up getting 6. So f plus g of negative 2 is 6. So we're going to have a point on the graph of f plus g of x at negative 2, 6. So we're going to have to do this a few times, right, for all the points that we want to graph. So let's keep it organized. We can do that with a table. Let's say we have x. We're going to need f of x, and g of x, in order to find f plus g of x. And then I'm going to leave a little space here so that we can calculate f minus g of x for the next question as well. It'll be nice to have those y values here already. Okay, so we just figured out what's up when x is negative 2. Let's fill in the values here. So when x was negative 2, f of x we said was 6. Right, f of negative 2 was 6. G of x when x was negative 2 was 0. This means that f plus g of x was 6. Awesome. So looks like we have some pretty nicely defined points at negative 1, 0, positive 1, and positive 2. So let's go ahead and use all of those x values. So negative 2, negative 1, 0, 1, and 2. Let's fill out the next line of the table. I'm going to save f minus g for y'all to try on your own in just a second. If x is negative 1, f of negative 1 is 3, right? That's the y value of the solid line. It's also the y value of the dotted line, right? So that means that g of negative 1 is also 3. And when we add those together, we get 6 also. Why don't you guys take a second to fill out the rest of these y values for these x values, and we'll come back when we're finished. Okay, hopefully we got 2, 4, 3, 3, and 6, 0. As we look through this f plus g column, again, all we're doing is just adding f of x plus g of x for each point. Here, we get 2 plus 4, which is simply 6. Here, we get 3 plus 3, which again, 6, and 6 plus 0, which is 6. So, very interesting that these all happen to be the same thing. That's not a coincidence. It just means we have two very particular graphs that we're adding together. but it didn't have to be this. It won't always be all the same value. Let's go ahead and graph this really quickly. So if we have the x value of -2 and the output value for this function at 6, what are some of the points on the graph of f plus g? I'm going to gather all the points in this in a curly bracket set. So we have the x value -2 and the y value 6. So that's 1 point. We also have the x value -1 and the y value 6. So that's another point. You guys come up with the rest of these points really quick. All right, did we get this? Very simple. We just start gathering x and y values together. So these are the points on the graph. Let's go ahead and graph them. So we have -2, 6 graphed already from when we did it up here. Next point is -1, 6. -1, 6. Next point is 0, 6. Next point is +1, 6. And the last point is +2, 6. So looks like our graph of f plus g is going to look like this. All right, so why don't you guys give this one a shot? Why don't you guys find the y values for f minus g of x, then find the set of points, and then graph it. Okay, so looking at our table, we have our y values. These are simply f of x minus g of x for each x value, right? 6 minus 0 is 6. 3 minus 3 is 0. 2 minus 4 is -2, etc. Then again, we're gathering x and y for each x value and writing the point, right? So x is -2, y is 6. X is -1, y is 0. X is 0, y is -2, etc. Then we're taking these points and graphing them like so. We end up getting sort of a deep parabola here. Awesome. Okay, let's look at a multiplication question. Okay, so let's say we're looking at this guy. We have all the points given to us. Let's go ahead and make a table. We have x, f, and g. And we want h of x, which is f of x times g of x, which we know as f g of x, f times g of x. So it looks like the x values that we have here are 0, 3, and 6. So 0, 3, and 6. What's f of x at x equals 0? F of x is this one. Looks like our y value is -3. G of x at 0 is +3. F of x at x equals 3 is 0. G of x at 3 is -3. And then at 6, f of x is +3. And g of x is -9. All right, so let's look at this one. So we've got f times g of x. F times g of x is just f of x times g of x, so f times g at 0 is going to be -3 times 3, or -9. F of g at 3 is 0 times 3 times negative 3, or 0. And f times g at 6 is 3 times negative 9, which is negative 18. Okay, so let's write a few of these points down. Some of the points that are going to be on this graph of f times g are, well, we've got x and y, so 0 and negative 9. We've got 3 and 0. And we've got 6 and negative 18. So we want to graph these points. And it's also telling us to make sure that we change the axis values to match the points you need. So if you're graphing this on your own paper, you can just write negative 18, right? That's easy, that's totally fine. This is definitely going to come in handy here because we have a point that needs us to graph 18, but this clearly doesn't have 18 grid lines, right? So we need to sort of adjust here. How can we do that? If we use multiples of 3, will that let us graph everything where we need to? Not quite, right? Because even if we need to graph negative 18, if we do 3, we have negative 3, negative 6, negative 9, negative 12, negative 15, and negative 18 is kind of off the graph. I think we should go ahead and just do it, and we can kind of say, we can kind of extend it a little. That's fine. Okay, so we graph these points. Again, each of these grid lines are 3. So we've got 3, 6, 9, 12, 15. Same thing here, 3, 6, 9, 12, 15. Our first point is 0, negative 9. So 0, negative 9 is going to be 3, 6, 9. Right here. Our second point is 3, 0. So just 3, 0. And then next point is 6, negative 18. So 6 and then negative 18 is going to be 3, negative 6, negative 9, negative 12, negative 15, negative 18 would be right about here. So we connect these points. It's going to look like this. Let's take a second to think about the shape of this graph. What are we doing here? Well, we're multiplying a line times a line, right? Lines have an x value. Lines look like mx plus b, right? They have 1x. If we multiply something with 1x times something else with 1x, we have something with 2x's, right? Or x squared. This graph is, it's not a coincidence that this graph looks like a parabola, looks like a quadratic function, right? Something with x squared. That's not a coincidence. That's just something to think about. Okay, let's go back to our notes really quickly. All right, so example. Let's say we have h of x, which is x squared plus 1, and j of x, which is square root of x minus 2. What is h plus j of x? Well, again, easy. Just h of x plus j of x, which here is just x squared plus 1 plus the square root of x minus 2, right? H of x plus j of x. What is h plus j of 0? Well, again, remember, we have two ways to figure it out. We can either plug 0 in here, or we can plug 0 into each h and j and figure out what we get. So let's try the first one first, since we have it already worked out. So we can just plug 0 in here. So that would give us 0 squared plus 1 plus the square root of 0 minus 2. That gives us 0, right? 0 squared is 0, plus 1, plus the square root of negative 2. But we run into something funky, right? What is this? It's undefined, right? We can't take the square root of a negative number. So this gives us no solution. All right, so we ran into trouble there. Let's see if our other method works for us. So let's find h of 0 and j of 0. H of 0 is just 0 squared plus 1, right? Or 0 plus 1, which is just 1, so that's okay. So we've got h of 0. Let's find j of 0. J of 0 is just the square root of 0 minus 2, which gives me the square root of negative 2, which is, again, an issue. Right? So if we can't find j of 0, if there is no j of 0, then there's not going to be a j of 0 plus h of 0, right? Then there's not going to be an h of 0 plus j of 0. We can't add something to nothing, right? So, because 0 is not in the domain of j, 0 is not in the domain of h plus j. So what does that mean in the grand scheme of things for us? Let's kind of broaden our scope here. The domain of f plus g, f minus g, and f times g is what's in both the domains of f and g. So what do I mean by that, by what's in both? I mean, if I'm looking at a Venn diagram and this circle contains all of the stuff in the domain of f, and this circle contains all of the stuff in the domain of g, then the domain of all of these guys, f plus g, f minus g, and f times g, is what's in here. So this is the domain of f plus g, f minus g, and f times g. So it's what's in both. So how can we find the domain of h and j from our previous example? So using h and j from above, find the domain of h plus j, h minus j, and h times j. Well, all this is asking us to do is find what's in both the domain of h and the domain of j. So what is the domain of h? Aren't our only domain rules that we need to look out for a denominator and a even root? Do we have either of those here? We don't, right? So since we don't have either of them, our domain is all real numbers. It's a quadratic, right? The domain of a quadratic is all real numbers, right? There's no real number that we can't square and get a real number. So the domain of h is all real numbers. What's the domain of j? Again, our rules are we're looking for a denominator or an even root. We do have an even root here, so what do we need to do? What's wrong with even roots? We can't have negatives underneath. So let's check the stuff underneath and see when it's going to be positive or equal to 0. So the stuff underneath is x minus 2. We want to set that greater than or equal to 0. We only want x values that are greater than or equal to 2. That means that our domain is 2 to infinity. Okay, so what's in both here? Well, if we have all real numbers and then only 2 to infinity, what's in both? Well, 2 to infinity, right? This is the domain of h plus j, h minus j, and h times j. Checking back to our example from before, right, where we said that 0 was not in the domain, is 0 included here? It's not. 0 is less than 2, so it's not included in our domain, so this checks out. Let's look at another example really quick. Finding the domain of f plus g for f of x equals square root of x minus 3 and g of x, which is 1 over x minus 7. We need to find the domain of f and the domain of g and figure out what's in both. So, domain of f, well, f has a even root, so what do we need to do here? We need to set what's underneath greater than or equal to 0. We end up getting x is greater than or equal to 3. What is the domain of g? So remember, we have a denominator here. What do we need to look out for when we have a denominator? We need to look for when the denominator will be equal to 0, because we cannot divide by 0. So when will this be 0? When will x minus 7 be equal to 0? Let's set it not equal to 0, because that's what we want, right? All we have to do is solve for x here, which means we add 7 to both sides. We get x cannot be 7. Okay, so what's in both of these sets of numbers? What set of numbers satisfy both of these conditions? This is very similar to what we were doing with domain symbolically, right? We're still kind of doing domain symbolically. So our numbers involved here were 3 and 7. We don't want to be equal to 7, so we're going to give that an open point. And we do want to be greater than or equal to 3. Right? So we're including 3 and everything larger than 3. But we don't want to include 7 because we said we don't want to be equal to 7. So we've got all this in here. The shaded numbers are the numbers that are included in our domain. How can we write this in interval notation? Well, we've got bracket, because we're closed point, at 3, all the way to 7, but not including 7, and then again from 7 to positive infinity. This is my domain. All right, that's all I have for y'all today. As always, thanks for watching.